Welcome to the Engineering Seed podcast.
Well, let's talk about this company then. So what is...
So at Electrical Projects Australia, I guess from the start, we were part of AMP Control.
Okay.
So I guess it was back in '86. AMP Control had a division that would basically design, using their equipment, design for mines and things like that. And our subsequent directors were the guys looking after that.
Yeah.
So that went on for 3 or 4 years, and then it got to the point where they decided, look, AMP Control gear's great, but it's not exhaustive enough to win enough work. And this is, I wasn't around back then, so this is what I've been told. And so they decided to sort of, I guess there was some sort of mutual agreement where they decided to splinter off a bit, and they obviously still use a lot of AMP Control gear on their designs, but then they got the option to use other stuff as well. And then basically after a few more years, it sort of morphed just out of not just mining into different sort of electrical engineering, I guess, what do you call it? Just different areas of electrical engineering. So I think at the moment, a lot of our work's actually coming through the commercial industry. So building services design, it's one of those things where you first look at it and you think, okay, I remember when I first started, I wanted to get really into the PLCs and all the control, because I thought it was more linked to what we learned at uni. And I didn't really sort of want to get too much into building services. But over time, I've realised it's actually really nuanced and a difficult thing to really understand well. So a lot of our work comes through that. So we do hospitals, schools. So we've got like clients like the government, the unis, private enterprise, and any building you see is basically a structural, civil, and electrical, mechanical engineer, an architect. We all get together, start the project, design it all up, and then it goes out to tender for the builders and the electricians and all those sort of guys to sort of build it. We just make sure that they, follow the design and certify it at the end. So that's one of our sort of, I guess, our bread and butter industries. Apart from that, we do a lot of HV work. So basically, we'll be designing substations. It's all private substations, so we don't do the level 3 work. So we'll get a project like a university, at a hospital, where they're going to build us a private high voltage substation, and that just means basically that it's not a authority substation. The client is actually a high voltage customer, so they run their own substations. And so we'll do all that design, we do all the modelling and earthing designs and protection studies for that sort of thing. And it's usually it'll be for a large project. So we a few years back did the grain terminal in Newcastle, which was the biggest grain terminal built in Australia, I think, for the last 25 years. So it was a pretty big job. So that we did all that. They had a number of substations and a high voltage network. Obviously, it went down to all the MCCs and all that sort of design as well. So it was a pretty big project for us, that one. We didn't actually do the programming on that one for the PLC. That actually went out. We were going to do that, but it went out to another company. But part of our work is definitely industrial and mining, but that's sort of gone to the wayside a little bit since the mining sort of infrastructure boom ended, I guess. Now it's a pretty competitive market out there for mining. So a lot of our mining work now comes from arc flash studies. So I don't know if you guys are familiar with those, but they're getting more and more traction now.
They are, all the clients that we sort of are getting involved with just keep saying that all the PPE requirements just keep getting more and more and more. So clients usually, whether it's either we have to wear arc flash all the time, or obviously if you're just going into a 415 board, you need to be arc flashed up.
So we do a lot of those studies, and it's not something we sort of went in to want to do, but we just get asked to do them. It's okay. So you need to go out and get, I guess, a professional, because it won't be something you learn at uni. You might learn a bit about energy systems and things like that, fault currents, zero positive sequence, all that sort of knowledge to learn at uni. But the actual practical implementing it needs to be done on a piece of software. So the only way you can do it is go get trained in that piece of software.
Yeah.
So you build all your models up. And, look, I find it interesting. It's pretty repetitive.
Yeah.
And it takes a lot of you really have to feel that you're getting it right, because you're using software. You know what it's like. You can build it all and you come out with numbers and you can just trust them, and you can't do that. You've got to make sure that you're really understanding, like, is it making sense? You go back to first principles sometimes and just, try to check the software.
Would you say that sort of knowledge comes through more of your previous expertise as opposed to industry since, your work since?
Yeah, look, I guess I did, before I went to uni, because I started uni when I was 20.
Yeah.
So I started an apprenticeship, it was in year 12.
Oh, okay.
As an electrician. So I started working, basically, I'd work a Tuesday, because we had Tuesdays off in year 12. And then I really wanted to leave school, and the teacher said, just hang on, you're almost finished. We'll let you work another day. So I worked a Tuesday and a Wednesday, and I ended up getting my HSC. My marks didn't go too well, but that's fine, because I'd already on the path of getting my apprenticeship. So I did that, and I think I was about finished my third year, and I decided that I wanted to probably go on to the engineering part. So I learned a lot doing an apprenticeship. It's a really good, it's not something that, well, it is, I would recommend doing an apprenticeship for anyone. I think there's a big gap in the industry for really good apprentices, and there's a really good pathway to become an engineer if you've done that. Look, don't get me wrong, if you already got the marks to get straight into engineering at UTS, for example, then do it. But if you're the sort of person that doesn't have the marks, or chose some subjects at school that you can't get your tertiary education marks for, then definitely go into an apprenticeship. It really teaches you a lot of hands-on knowledge. They don't go into the depth of maths when you do your theory, but they give you, they give you a good grounding of why things happen. And there is a bit of algebra and things like that, but it's not too hard. So I did learn a lot from that, and I guess it gave me a taste of what work was like. And I saw the engineers, I got to meet them, I knew what they did and what we did, which is something that sort of is a gap in, it's just not there for the kids when you start what we're really going to do at the end. And I sort of had that, this is the person that I want to be. I could see that, it was great doing an apprenticeship. I could see some really skilled tradesmen, but at the end of the day, I saw the engineers come on site, and I thought, wow, that's what they're doing is really something I want to be doing. And that's why I got into uni. That's why I decided to go to uni. So I did learn a lot from that. But look, there was a couple of good courses on power engineering at uni, where I learned theory around, calculating fault currents, doing load flow studies. That was probably the most practical subject we learned. And that did then feed in when I went to do my courses, and they're not cheap to do these courses. They're like $5 to $6 grand. So you got to get with a good company that wants to train you up. There might be a 2-day course in software, and you go off and do that, and that, all those, I guess, 3 parts of my knowledge all come together, and it did give me a good understanding of it. But you still got to do the work to really know where you need to do the work to understand what's happening. You can't just jump straight into it. You need someone above you to be saying, well, is this right? And you think that's right. And it takes a good few years before you're really confident in yourself.
So the industries that you're in for this company, more building services and stuff like that, as opposed to...
Well...
Are there any other industries that you're in?
So there's the building services. We do a lot of... we are in mining. It's just... It ebbs and flows with the market, and we pride ourselves on being able to go with the market. And I think the last major job we did in a mine was at a coal washery up in Hunter Valley, and that was probably 4 or 5 years ago. And after that, there was it was sort of the end of the mining infrastructure sort of building boom that was there, and we got out of it after that. So as I said, from that point on, we still do mining work, but it's usually desktop stuff that we provide, like arc flush studies for and things like that. What else? We do a lot of, which seems, it's not hugely relevant to electrical engineering degree, but I guess in some respects it is. We do a lot of NBN design. So what happened was the NBN have two sort of things they're trying to do. One is to run NBN to all the existing buildings, and the other one is there's obviously new buildings being built that need NBN.
Yep.
And so we do a lot of what the new infrastructure that's going in, so for the developers, and we actually got knocked on the door by NBN to say, look guys, we're looking for guys that can do this sort of design.
Right.
It's not hugely technical, so that we're happy to help, and so we've set up, and we do all over Australia. We do NBN designs.
Okay.
So it's mainly our pathway. They call it pathway pin pipe designs. So you need to understand how the fibre distribution works, and then you put in all the pathways for it.
Right.
The developer will hire someone like an electrician or a communications contractor to install this pathway, and then NBN will come and pull their fibres through. So yeah, we do a lot of that. We do a lot of energy auditing, things like that for companies. It's usually for a bank or something like that, or a big institution. We know what sort of energy they're using, what sort of recommendations we can make to bring down their energy bills and their emissions and things like that. So we definitely get into that. We're working with local councils. At the moment, we're working with the local councils here, and they're doing you could almost describe it as a microgrid at their administration building. So they've got currently 160 kilowatts of solar. They get another 160 put on soon at one of their car parks, and they're also getting a Tesla battery. So one of the big ones that you see, in South Australia. So they're getting I think it's a 250 kilowatt battery.
Yep.
And they're getting a heap of car chargers, because they're actually ordering some EV cars.
Yeah.
And what they're planning to do is to use their chargers for, basically use their battery to go back into the building as well. So it's all about, pulling it all together, having a bit of control. We'll have a PLC where we can shed certain loads.
Yep.
And their end goal is to obviously to bring down their power bill, bring down their max demands, flatten out their load profile, but also to act as a disaster relief mode.
Yep.
So if you've got a huge storm and everything drops out, then their battery will start, supplying power to the building.
Or the building.
To the building. It will, in normal operations, it will feed back to the grid.
Okay.
And so with the cars, they're getting, I think they're getting some Nissans. They've ordered some Teslas, but I'm pretty sure the Nissans are the ones that can go back into the grid at this stage. But for disaster relief mode, it's just making sure that they've got power there, so they can coordinate all the, RFS or whoever they need to coordinate the councillors.
Okay.
And it's about controlling load. Obviously, you don't want huge loads that's going to deplete the battery for no reason, like perhaps we'll turn off air conditioning, or maybe only have one floor for disaster relief mode and be able to scale, as you're running out of power, you'll be able to say, right, this floor will have to vacate it, we're running out of power. I guess the problem with that is that, I can explain it to them, if you're out for a few days, you're probably not going to be able to keep it up, so they do have facilities for just the diesel generators as well.
Yeah, of course.
But it's just about controlling that, and the main thing they want to do is bring down the peak, because that's a big part of their bill, their network. If they can bring that down, they get real big payoffs financially. And I've sort of had the conversations with their energy efficiency guys, and they understand it really well. There's some good guys on their team. That if you really want to look at it, if the end goal is to bring down your CO2 emissions, you really want to be able to guarantee that you're never going to hit that peak, because if you're hitting these peaks, the way it translates is that you need dispatchable power, and dispatchable power at the moment is carbon fuel power. So if you really want to do the right thing in terms of CO2 emissions, you have to make sure you don't ever do that. So if everyone could do that, then you could start turning off more power plants and things like that. So they have to come up. Look, their overall average power might be really low now, but if you really want to make sure that you don't need dispatchable power, you need to bring down that peak. So they're going for a bit of a, philosophical think about what do we want to do. Do we want to guarantee that we've got solar in our batteries? They got to guarantee that they're not going to go down, basically. That they're always going to be running, because even if you get one day where you need double the amount of power than you usually use, then there's a market there for a dispatchable power or a coal power plant, that base load that's it's always there. So
Yep.
that's the sort of interesting things we sort of need to deal with in terms of that industry. What else we're doing? We've been asked at the moment, we're working on a few different projects in terms of like workflow analysis and things like that. So at the Newcastle University, we've basically done all the master planning for that. So over the next, until 2035, what the uni will look like. We want to make sure that they've got a private high voltage network with 30 substations and how all their loads are going to flow. It's a multiple ring sort of topology, and just knowing if this particular substation fails, where does all the power go? Is it going to overload? So we do all the master planning for that, and that I find that pretty interesting. We do everything from huge hospitals, really big projects, to tiny little ones as well. Tiny little ones we do. Some, obviously there's some people out there that want to build really, how would you say it? There's people out there that build really nice homes. And they've got a lot of money to spend and they want to have a really smart home. So we will get engaged by the architects. I mean, it's not a huge job, but it's an interesting job because you're building a smart home. Like they have, the client wants, the owner wants something, and you provide it for them. So they'll have all voice automated systems, and they'll have Tesla batteries, and they'll have solar, and it's just it's a nice little tight job that you can bring together using some of the technologies that you use in your home, which I always find interesting. We've been doing some work for NDIS. So they're building facilities for people with severe disabilities that are still independent. So it's basically an apartment building. Then there might be one apartment for a carer if they need it, and then they have their own apartment, and they can. So it's basically a smart building for them, so they can do everything without having to. If they've lost mobility, they can do everything they want through their voice or through some sort of command. So it's basically a smart home, but on a bit of a bigger scale. So we're doing a bit of that these days.
So are you just electrical engineers here? Do you have...
We are electrical engineers, so I guess you cover the whole electrical industry in some respects. So we have engineers that have come through TAFE. So we have a lot of those guys. We have degree engineers. We've got electrical drafters, which we find really valuable. They are basically people that have got a little bit of electrical knowledge, but come from a documentation point of view. So we have a team of drafters as well. That's it. We don't have any other engineers that work here. We've been pretty focused on the electrical industry. I think it's a unique sort of way to go, because a lot of companies will have multidisciplinary engineering, but our runner, our owners like myself and the other director, we're all electrical minded. So it's sometimes I use the analogy of a doctor's surgery. It's run by the doctors, it's owned by the doctors. You are a doctor, you're not an engineer that's working for someone else, doing what they want you to do. And through that I've learned a lot about business, which is that just takes time to get a feel for the industry, to know that in business you just got to spend the time to meet everyone in your industries, to build relationships with them, so they always come back to you and ask for more work, and that takes a lot of time to build that, but it's something that really I enjoy doing. And you also get to learn about running a business is the same for every business. So I've learned a lot about business. A lot about business, and sometimes I enjoy that sort of things as much as the engineering. Because you're building something, and if you can build something, and you can hire more people, you get enjoyment from that. And, people really enjoy the work here. Our staff really enjoy the work here, and it's something that I enjoy. People that enjoy working here, and I enjoy teaching people. Our staff teach me things. So it's really good.
That's great. Maybe to put a bit of a student spin on it, to sort of give maybe guidance for people that are going through uni, what are some of the things that, whether you found it going through uni or now looking back as you build people up in your position, what are some of the sort of key skills that you're looking for in people? I guess usually it's not necessarily technical.
So look, I think one quick bit of advice before I get too far into it, I give to any student, is to go and knock on some doors. Go say, look, this is who I am, I'm looking for work, even if it's a day a week, casual work. If you knock on enough doors, you'll get a job, and that's something that if you can sort of, it can be a bit scary when you're, a couple of years out of school to do that. You think, well, I don't want to get the door shut in my face. But basically, a lot of the people we hire are those sort of people. We want someone to be reaching out, and I guess it leads on to the sort of skills you want. You want to be able to sort of be confident, go in there, and understand your limits, but also it's the thing with engineers as well. They'll just say yes, we'll fit in, without knowing if they can do it or not. As an engineer, you say yes, I can do that, and then you sit down and you try to figure it out, and that's an important skill to have. So I guess communication skills. You don't have to be a wordsmith or anything like that. You just need to be able to pick up a phone and be happy to talk to someone. So your confidence talking to people. There's obviously soft skills like just being able to write reports. It's a skill that you do learn at uni towards the end. I think you get good at it, but when you sort of writing a report at uni, you're writing for someone who's usually technically above you. So you're trying to bring in all this technical stuff, where when you're in the real industry, out in the industry, we're talking to someone that doesn't have the technical background. So you've got to sort of strip away some of the technical things and try to relate to people on their level a bit. So learning to do that and how to frame things for your client, frame things for your report, whoever you're going to be writing a report for. You might be an electrical engineer that's working, for a agri company, and your person you're reporting to is not an electrical engineer. So you need to be able to understand who your audience is when you're doing that sort of thing. Obviously, we like technical skills as well. And we always encourage guys to keep growing that. It's a big part of development of our company, because usually the leadership of companies have been out of the university for a while, so they don't know all the new stuff. So we really need the young guys to be coming up with that knowledge to put it through our company. So we value that and try to use that as much as we can. Like an example is we're working on a lot of schools at the moment, public schools, and we've got the directive from the guys at Department of Education to come up with some innovation. It's like, what sort of innovation are you talking about? They kept on asking, so okay, well, what we'll do is we'll put in some network metering throughout the site, throughout the school, and that will hook back into communications, like Comex, which is basically just a server with some communications protocols built in, and a PLC. And then what we'll do is we'll aggregate all the power usages for the kids, and we can output it then to their they've got screens on walls. They don't have like blackboards, but onto their screen, so the kids can get taught how much power they're using.
That's great.
And each classroom will have a traffic light, basically, which is just red, green, and yellow. And they can all see it's a big traffic light on the wall. They can see how they're going. If their solar powers, if you're generating more solar than you're using, you'll get a green light. So the kids can in real time say, all right, should we put the aircon on? And you put the aircon on, and you'll see. You're using a lot of power now. You're not going very well, and the traffic light will go down. So to have that sort of the uni students coming in with some of the knowledge that they're bringing these days, we needed to build a Ubuntu server, because it all goes out to the cloud, and we will aggregate it because there's multiple, user interfaces that we need to build. Using like a web app, and so you'd be able to log in as a school. Get your particular web app up. Now that sort of, programming knowledge is just not something that we had. Because it's sort of that it's like a recent sort of knowledge that they've been coming through the universities. So that to build that that server and put it on Azure and have a cloud-based platform is something that we've got from the kids, from the new uni students. So we try to use that information, that new knowledge that's coming through the kids to build our overall companies.
That's great. Is there on that then any sort of other areas in the industries that you're in where you see the future going? Whether it's energy or like maybe IoT or anything like that.
Yeah, sure. Look, we do a lot of work for local councils as well around IoT and smart cities. So it's definitely something that's getting traction.
Yeah.
And with IoT, you've got to build an IoT network, but then you've also got your components in your IoT. So that's something I think we'll start growing in Australia. The people that are building the components that will be speaking to the network that we'll set up the network, but we wouldn't build the particular device. It might be a temperature sensor that will talk to the network. So we'll help set up the network for the council. But there's all these other products that's coming along that I think is going to be something that there will be a growing industry for. In terms of energy, I definitely see that for the next, 20 years, there will be a big push to roll out localised solar and batteries. And the batteries are really now coming on. It wasn't always something that people asked for a while, but they're now starting to get over the line. With their return on investments, it's there for them, for companies to do. So that's definitely something that I think at least for the next 20 years, I have a feeling that eventually, once the network operators and the generation guys transition to a different sort of technology, I think it will probably, in my opinion, will revert back to being, you'll just be a consumer, and the low emission technology will be out there on the large scale. So I definitely see for the next 20 years that everyone will be doing their own little part, but I can see there will be a transition one day where it won't be as financially profitable to put a solar panel on your roof because someone will be doing it at scale and you'll just be using their electricity, same as what we're doing now, but it'll just be there'll be less CO2 emitting plants. Look, in terms of how we work in our office, we're doing a lot of stuff in a program called Revit now, which is a 3D modelling program, and it's a collaboration program between all the engineers and architects. So that's really interesting. It's a lot of hard work to get trained up in that.
Is that like an overall sort of AutoCAD
product? Exactly.
A similar thing?
Exactly. So the architect will basically start laying out the building in 3D. So there'll be everything. You'll have a chair, and the chair is a family. It's like a 3D model that's got its own little sort of sandboxed, design that you can drop into a project. You'll have a PowerPoint or an air conditioner that will be on the wall, and it will be the 3D model, but it'll also have the electrical characteristics as well. So we'll be doing a building services design, and we'll put in all our equipment. And then you start building up an electrical network in the background. So there'll be a 3D model you can walk through in VR, which, it's pretty fun. And it's a good way to, sometimes when you're doing designs and you're seeing it on a 2D plan, it's really hard to get that feel of what's really happening. So it's really good for that. You can do cool renders and see, well, this is what the idea of what they're going to build is. And it makes it a lot easier as an electrical engineer to design for that. But also in the background, it's doing a lot of the electrical calculations. It takes time to build up this equipment because there's not really a good library system out there. So you need to actually go there and say, well, this is the power that's coming out of it. And, this is the current, this is the harmonics, whatever you want to put in there, you put it in there, and then you start joining it together. It'll start telling you how much power you're using. It will set out some panel designs for you, schedules for it that you can do your switchboards and things like that for. You can do a lot of the lighting design. Obviously doing buildings, there's a big portion of these lighting designs. So in the lighting design sort of realm, you're doing 3D models, you're putting lights into the room, you're making sure that you've got the right lux levels and uniformities, and there's a whole horde of Australian standards out there, which you don't really get taught about at uni. But that's a big part of being a practicing engineers is getting your head around that, but they'll feed in to the design so you can actually see what your light looks like. Full renders, like you'd see come out of computer games. So it's pretty cool. You will get sun coming into the building, and you can see how that contributes, and then you can do things like sunlight modelling, so you can do dimming of your light, that sort of stuff. But that is definitely something that I think is the future for a portion of guys coming out of uni is learning that software. Definitely in our industry, and that's one of the things you really need to understand software a lot. Because AutoCAD is more a drawing. A drawing, drawing a line from here to there, basically. Where this is more creating. You need a bit of software engineering, I guess, knowledge, because you're creating. It's almost, you can see the methods and classes that you're creating is basically class chair, and the methods to define the chair in that class, but it's all done modular, so you can't really see, but you need to get understanding, how does all the nested things work within the software. If you don't understand that and you're just trying to pull it all together, it doesn't quite work. So I found that a lot of the guys that go really well with the Revit are the guys that have a good grasp of computer software engineering. You don't do much software coding. There's modules where you can code. Obviously, which is really valuable as well. But just understanding how all that works, how computers work, and how software engineering works, they're the guys that usually pick up the Revit really well. So that's one thing I think in our industry, from like a workload point of view, that's coming up rapidly.
Great. Fantastic. Thank you so much for your time. This has been great.
Yeah.